So today we're going to talk about generating and modifying our data in STATA, and we're first going to start talking about importing data. And last time we imported data using the infex command when it was importing raw data. But what if you have data like the data we're going to be playing with that's in Excel? And here's some health data that we are going to be playing around with. Measures sugar content of somebody in somebody's blood, gives their sex, gives their blood pressure, weight, and height. And one way we can put this into STATA is just copy and paste, which you just highlight, right click, copy. And then I go into my STATA, and instead of going to my data browser, I'm actually going to go to my data editor, click on it, and just right click and paste. And there's our data. One thing you'll notice right away is that sex is coded as M and F, not as a numerical number. And in STATA, this is called a string variable. And we can, it's okay to be a string variable for right now, but we may need to convert this to a numerical variable. Let's go ahead and close this. And you see that just by copying and pasting, all the variables were put in. All the names of the variables are identified. And even for labels, the STATA automatically assumes that the name and the label are the same thing if it's just one word. So sex, the label became sex, and SPP, the label became SPP. So everything is already in there. Let's say we didn't want to just copy and paste, or we had a different type of data file. We can just go ahead and also convert things with STATA transfer, which is a software that you should see in most of the data center computers here in Minnesota. It's usually in the desktop. It's over here, and you just double click on it, and this window comes up, and it's pretty self-explanatory. You just choose the type of input file. So for us it's Excel, and we specify well, we got to find where it is. So us is example 1. Just double click on it, and then we just gotta do output. And we're using STATA, but you could have done it for SPSS or any of these other programs. We'll just do STATA standard, and then we tell it where we want it to actually create that new file, and it's going to create it in our desktop here. So just click on transfer when you're happy, and it says that 25 cases were transferred. And now if I click on this, STATA opens up the file because it's just data file, and it loads up the data automatically. You can look up on your data browser and you'll see all the variables there. And now that I have my data uploaded, I'm just going to open up this do file editor that I already have worked on. And the first thing I'm going to do is just label things, because my STATA transfer didn't label anything from my Excel file. This wouldn't be the case if I was changing like an SPSS file to STATA, but Excel doesn't have labels. So first thing I'm going to do is just create labels. And here you can see the labels are created. And let's say you know, we're talking about manipulating data, and we actually want to create a new variable, not just, you know, run frequencies or analysis on one variable, but we actually want to create another variable. And with height and weight, and when we want to create a new variable, the basic syntax command is called generate. And you generate and you give a new name of what you want that variable to be called. And then you tell STATA what that new variable should equal. And here you may put, in reference to another variable, you may put an expression like ×2 of something. So for instance, if we have all this health data, weight and height in particular, we might want to create a new variable called BMI. Which is taking into account one's weight and one's height. BMI equals height and weight divided by height squared. In our data, we have height in kilograms and height in meters. So all we would need to do, and you can see my do file, is type generate BMI. So it's creating a brand new variable called BMI equals the variable weight divided by parentheses height over 100 parentheses to the second power. And because it's in centimeters, we divide it by 100 to have it in meters. This is just because that's what the BMI formula is. So if we run this, it'll create this new BMI variable just as we specified it. So I'm going to go ahead and click Run. And if we open up our STATA window, we'll see that BMI has been created. You can take a look at it if you want, but everything should be okay. And there you see BMI is a product of height divided by, weight divided by height squared. Let's say we want to create another variable that they all often use in health studies, which is called the body surface area. And body surface area is, you're also looking at weight and height, but you're actually calculating it or timesing it by a particular set of numbers. So it's this body surface area equals 0.024265 times the height in centimeters to this power of 0.3964 times the weight in kilogram to the power of 0.5378. Now, whatever formula, however you want to manipulate your data, you just need to specify it as such in the generate command. So what we're going to do is going to generate this new variable called BSA. And here you don't actually even have to spell out generate. You can just type in G. So generate, create out of thin air, this BSA equals this number times the variable height to the power of 0.3964 times the weight variable to the power of 0.5378. Sounds complicated, but all we're doing is creating a new variable with this function. So I'm going to, and you can see here my do file. It's exactly what I did. GBSA equals this product term to the power of 0.394 times weight to the power of 0.5378. And I just highlight it and run. If I want to create another variable, look at the mean arterial pressure. Is you just take these two types of blood pressure, diastolic and systolic blood pressure, and you put it in this formula. It equals 2 times systolic pressure plus systolic pressure divided by 3. That's just a formula that we got from a health book, and commanded into STATA. So what we're going to do is G, again for generate, MAP, and MAP is a new variable that we're creating out of thin air, equals this formula, 2 times this variable plus this variable, close parentheses, divided by 3. So if I go to my STATA do file, you can see this is exactly what I wrote out. G, create this map variable according to these specifications, and then I just run it, and STATA should have created a new variable. So if you look at your browse, you can see that we've created 3 variables just by this generate command. And the generate command is always generate a new variable equals a particular function. So just playing around with weight and height, we've generated already 3 different types of measurements. So now that we have these variables, one thing we might want to do is just label them. And let's close it, because you can't do anything until you've closed the browser. Look at my do file editor. Label variable, you just type in lab var, and instead of typing out the entire thing, label variable, you can just use these abbreviations. The BMI is the variable, and put quotation marks for what you want to call it. So BSA, it's body surface area. MAP is mean arterial pressure. And if we just highlight these things and run it, the label will be applied. Okay. So now that we've created these 3 continuous measures, BMI, BSA, and MAP, you could just run some basic analyses, such as summarize them in terms of means and standard deviations, or you can create a histogram with this hist command, hist BMI, for instance, and that create a histogram for that variable. And then you can do a correlation matrix for all those 3 variables. So how is BMI, BSA, and MAP correlated. They're probably very heavily correlated since they all use the same basic construct of height and mean. So that's the generate command. Now you could do that in SPSS, and one of the things we want to show you here is actually an additional feature of STATA that you can't do with SPSS is this eGenerate command. And this eGenerate command is actually quite handy. Let's look at our data really quickly. And I think I said already that these first 5 measures is measuring the content of the sugar levels in somebody's bloodstream. So this was taken basically at when somebody was eating breakfast, 30 minutes after they ate breakfast, 60 minutes after breakfast, 90 minutes after breakfast, and 2 hours after breakfast. So this is one individual with 5 different measures. Let's say that we wanted to have an average for these 5 different measures, and that's what the eGenerate command can actually do. It can look at 5 of these variables, and we'll create a new variable that will be called the mean of this row. We could also do standard deviation and the minimum and the maximum of these rows. Now, a cool thing about this generate command is that sometimes we have missing data. So, for instance, number 11 here, we only have data for 4 out of the 5 periods. And if we create an average of that, it's going to be a skewed average because we'll have 4 instead of 5 data points that we'll be comparing. But STATA is smart enough that if you have a missing value, instead of dividing by 5, it'll divide by 4. So take the real average and won't give you a skewed average. And so we have quite a few missing data points here. So some people actually only have 3 values that we want to average. Some people have 5 and some people have 4. And if you have thousands of respondents, that's going to be hard to keep track of. But this eGenerate command can do that. Let me close that and show you the syntax. And instead of writing eGenerate, I just put eGen. Then I named this new variable that I'm going to create out of thin air called min _ mean. So the mean of this min variable equals row mean. And row mean is a specific type of calculation that STATA understands. It's going to calculate the mean of the row. Then I specify the variables that I wanted to calculate across. And you'll notice here I didn't actually list all 5 variables. I listed the very first variable, and then I listed all the way to the last variable. And STATA will take any variable that's in between and assume that that's going to be part of the calculations. And so if you look at my data view one more time, we see that these 5 variables are next to each other. So if I start in this variable and I go all the way to min 120, it's going to capture 90, 60, and 30. Now if 30 wasn't placed here physically in the data but was somewhere else, then it wouldn't capture it. So it does it by location. So it's good to know how your data is structured before you use that eGen command. And because I have it specified like that, all those data points will be included. The next thing I generate is standard deviations, and like last time, I eGenerate this variable called min SD equals row SD, and this is the specific command that STATA understands to create standard deviation of the rows between these variables, starting at min 00 all the way to min 120. So it's going to capture all of the 5 variables, and this is the same logic that I have for calculating the maximum and the minimum across these rows. So if I want to get a range, and if I just highlight and run, we'll see that we have 4 new variables generated. And again, if we just look at the data browser, we see now that we have 4 new variables, and I might need to move it over a little bit. Okay. And here they are, and yeah, it just took an average of those sugar readings, those blood sugar readings, and calculated so, and it also gave me the minimum, the maximum, and the standard deviation. So that's the eGenerate command. It's quite handy if you have, if you're looking at averages over time, or across variables, and you have a lot of respondents, so you don't want to think about how many data points I have for each one.